So, hi again, everybody. As I've been saying for the last wee while, we're getting towards the end of the electricity course, and the last kind of bit we need to do is to do with electronics. And the first bit we're going to look at are what I've called sensing circuits, which basically are circuits where you have some physical quantity, but you want to change it into an electrical quantity. So then you can control things with that. It'll become clearer when I talk through the rest of the PowerPoint. But that's the kind of basis of it. And we're going to look at a couple of sensing devices that I've mentioned in the past, which is an LDR, light dependent resistor, and a thermistor. Okay. So first thing to look at, and there's some dodgy camera work here involved. So the first circuit we're going to look at, that's the symbol for an LDR. Remember, the arrows pointing in the way show that it's a resistor that's reacting to light. And all we're doing here, very simple circuit, we're just connecting it across an ohm meter. So all we're doing is measuring the resistance of the LDR. Okay, so you just need to watch the screen when I click the play, watch what happens when I cover the LDR. So just now there's a certain amount of light reaching the LDR, and what I'm going to do is I'm going to cover the LDR, and what that's going to do is decrease the amount of light and see how that affects the resistance. Okay, so we're getting a reading of about 0.6 kilo ohms, and when I cover it up, you can see that the reading jumped away up to, well, I missed what it was. Let's just wait again, it goes on a loop. So it jumps up to, there we go, 6 kilo ohms. So when the LDR is covered, its resistance increases. I didn't do this on the video, but the opposite would be true if I shone light onto the LDR. The opposite thing would happen, the resistance would decrease. Now that sounds a wee bit confusing. Simplest way to remember that is like this kind of, it's called an acronym, LURD, and that just stands for if the light increases or goes up, then the resistance goes down. Now I've done this before, but it's one of these inverse kind of relationships. So if you increase the amount of light, the resistance decreases, or vice versa. If you decrease the amount of light, the resistance goes up. So that's the first thing, that's the first basic thing we need to know about an LDR. I'm going to do the same thing for the thermistor. So this is a resistor, remember, which is sensitive to temperature, so its resistance depends on temperature. Again, same circuit as previously. I've got the ohm meter connected straight across the thermistor, and all I'm going to do in this video is I'm going to heat up the thermistor by putting my fingers around the thermistor. That's the wee thermistor there, and I'm going to heat it up and we'll see what happens to its resistance. So again, looking at the reading on the meter, we're at a reading of about 18, just over 18 kilo ohms just now, and that would be at room temperature, but I'm going to heat it up because my hands are obviously warmer than room temperature, and we'll see how that affects it. So keep watching the screen. As I say, dodgy camera work, and you can see this time the resistance of the thermistor decreases. So basically this bit here, when we heat the thermistor or we raise its temperature, its resistance decreases. And if I could do the opposite, well, it does do the opposite. If I take my finger away, you'll see what happens. When I take my finger away, the resistance starts to go back up again. And this one, the acronym, always gets a bit of a laugh if you get the joke. It's TURD, and that stands for temperature up, resistance down. So again, it's another one of these ones. If you increase the temperature, the resistance goes down the way, or decrease the temperature and the resistance increases. It's an inverse kind of proportion thing. So moving on, I didn't do this camera work, but yeah, hopefully I'll be able to explain in more detail what's happening. So the next stage in using these circuits is we connect them in a voltage divider circuit. So I've got two circuits here. We're just going to focus on the first one first, funnily enough. So here's your LDR as part of a voltage divider circuit. Now remember back to voltage dividers, we've got a variable resistor in here. Later on in the course I'll explain why we use a variable resistor, why don't we just use a fixed value resistor, but that's for later on. So this, remember, two things about voltage divider circuits, that the voltage across this part and the voltage across this part has to add up to the supply voltage. The second thing from the voltage divider circuits is that whatever, if you, a larger value of resistor, so if these were two fixed resistors and one was bigger than the other, a bigger value than the other, then it would get a bigger share of the voltage. So it's all to do with the share of the voltage, and that depends on the ratio of the resistors. Because these circuits, the resistors are not fixed, or this resistance isn't fixed, it's going to change with light level, then that affects its resistance, which therefore affects the voltage across it. Okay, so I'll set the video playing. Basically, I've set up this circuit here on the video. So we've got a variable resistor at the top, so 22k variable resistor, doesn't matter, LDR at the bottom, and we've got two voltmeters. That voltmeter is measuring the voltage across the variable resistor, and the bottom voltmeter is measuring the voltage across the LDR. All I'm doing here is adjusting it so that we've got roughly equal values in here. Okay, so what I'm going to do this time is I'm going to shine a wee light onto the LDR, and you watch what happens to the voltage. So we know that if we increase the light levels getting to the LDR, its resistance is going to decrease. Now, if its resistance decreases, then the voltage across it also decreases. Now, what that then means is that the voltage across the variable resistor has to go up. Now, we've not changed the value of the variable resistor, but it gets a bigger share of the voltage because the LDR gets a smaller share. Its resistance has gone down, so therefore it gets a smaller share of the voltage, and the variable resistor up the top gets a greater share. Just repeating that a couple of times so you can see what's happening. Now, next part would be, well, okay, what happens if I cover the LDR? So if I reduce the amount of light. So if the light gets darker, the resistance of the LDR increases, the voltage across the LDR increases, and the voltage across the variable resistor decreases. Now I'm going to switch it around and swap these two components around. So now we've got the LDR is up the top and the variable resistor is at the bottom. We're going to start off by covering it up. So this time, as the light gets darker, the LDR's resistance would increase. So the voltage across the LDR increases, and the voltage across the variable resistor, decreases, and the voltage across the variable resistor increases. So I've lost track of my time here. The opposite was true there when I shone a light on the LDR. I've kind of went out of sync a wee bit, but when I shone light on the LDR, so that's the light level increasing, so its resistance decreases, so therefore the voltage across the LDR decreases and the voltage across the variable resistor increases. It's a wee bit complicated. There's a lot of, as one thing gets bigger, another one gets smaller, and so on and so forth. There's a lot of variables because you can vary the amount of light, but you can also vary the position of where the LDR is, and the circuits behave in exactly the opposite way when you do that. So that was the experimental stuff. So we're now going to try and get a note about this, and it's really, this is quite complicated, it's quite tricky to follow, so try and go through it with me. So this is the first circuit that we had in the previous slide we've got a LDR at the top, and we've got, no we don't, we have an LDR at the bottom, and we have a variable resistor at the top. Now, the thing about where the voltmeter is, now in the next set of lessons, or next PowerPoint, the reason why this voltmeter is here is important, because this is what we're going to be looking at to control something else later on. So what we've got is a circuit that reacts to light, and it can produce a voltage, but it's a very small voltage. We're only talking about 5 volts in this case. That doesn't really do much. So therefore, we can use that voltage though then to control something in the next part. So let's go through it and see if we can make head nor tail of it. So if we increase the light level on the LDR, remember it's a kind of inverse thing. So the resistance of the LDR decreases, and so therefore it gets a smaller share of the supply voltage, and the voltmeter reading in this case would decrease. Because remember, the voltage across the variable resistor and the voltage across the LDR must add up to the supply voltage. So if this voltage is decreasing, then the voltage across the variable resistor must increase. And if we did the opposite, and here's another variable way to look at, instead of increasing the light level, if you made the light level smaller, you decrease the amount of light, in other words, covering the LDR, its resistance is going to increase. The resistance of the LDR will increase, and so therefore the voltage across it will increase because it gets a bigger share of the voltage. At the same time, the voltage across here would decrease, but we're not bothered about that because we're not monitoring it, we're not using it. It's this voltage across the bottom component that's going to go on to in the next stage of these circuits. So this circuit is a circuit that's sensing low light, and what it would be able to do is with other parts to the circuit, it could control something, switch on something when it gets dark. That's the meaning of this circuit, but that will be covered in a later video. So this circuit is just switching these components around. So now we've got the LDR at the top. We're not monitoring the voltage across it. The voltmeter is across the LDR. Sorry, across the variable resistor. Keep getting that wrong. Never mind. So this circuit, the first bit is exactly the same. That doesn't change. If we increase the amount of light reaching the LDR, its resistance will decrease, and the voltage across the LDR would decrease. So then how does that affect the voltmeter reading? How does that affect the voltage across the variable resistor? Well, remember, voltage across there's got to add up to the supply voltage. So if that voltage is getting smaller, this voltage must be getting bigger, and so therefore the voltage across that is increasing and the voltmeter reading is increasing. So that's just saying that again. This means that the voltage across the variable resistor would increase and the voltmeter reading would increase. So this circuit is a high light level sensing circuit. So this circuit is monitoring when something's getting too bright or too light, then it would control something else in another part of a circuit. Okay, this maybe sounds a wee bit strange just now because you have no idea what I'm talking about, but in the next lot of lessons or at some point in the future, we go on to the next stage where we add in another component, because this voltage that we're getting here, so we're monitoring some physical quantity. In this case it's light, and we're getting a voltage, and that's a useful thing because that voltage can then be used to control another circuit, as we'll see in the next bit. Okay, so same sort of idea, but this time we're looking at a temperature sensing circuit as a part of a voltage divider. So this time we have the variable resistor here, we have a thermistor across the bottom here, and we're measuring the voltage across the thermistor. This is the voltage we're really interested in because this is the voltage that, as we say later on, will become our output voltage and will be used to control something else. Here we have the exact opposite circuit, and we can take it from there. Okay, so we have same idea, variable resistor at the top, thermistor at the bottom, 2 voltmeters again. There's our simple voltage divider circuit. Remember, the voltage across this variable resistor and the voltage across the thermistor has to add up to supply voltage. In this case, it's about 5.5 volts would be the supply voltage. And we're going to see what happens when I either heat the thermistor or let it cool down. So, first thing to do is heat the thermistor. Let's put my finger over the thermistor, and its resistance decreases, and so therefore the voltage across the thermistor decreases because it gets a smaller share of the voltage. The voltage across the thermistor now decreases, and you can see that the voltage across the variable resistor increases. Okay. Now we're going to switch the components around. So we're going to build this bottom circuit and see how that operates. So now the variable resistor's at the bottom, and that's the voltmeter reading is going to be across that one. We're only looking at the bottom voltmeter reading. Thermistor at the top. Heat the thermistor this time. Its resistance decreases, that stays the same. The voltage across the thermistor still decreases, but now the voltage across the variable resistor increases, and because it's at the bottom, in my circuit diagram here, it would be the reading on the voltmeter would increase. And so therefore, if you did the opposite, if you decreased the temperature of the thermistor, its resistance would increase, the voltage across the thermistor would increase, and therefore the voltage across the variable resistor would decrease. So the theory behind all of that stuff. So here's my first circuit with the thermistor at the bottom. And in this circuit, if we increase the temperature, then that resistance decreases, which therefore means the voltage across here decreases and the voltmeter reading decreases. Therefore, on that principle, the voltage across the variable resistor would increase. So, and if we do the exact opposite, if we decrease the temperature to the thermistor, then the circuit behaves in exactly the opposite way. So decreasing the temperature will increase the resistance of the thermistor, which therefore means the voltage will increase because it's getting a bigger share of the supply voltage. The voltage across there would decrease, but we're not bothered about that really. We're really just interested in the voltage across the thermistor in this circuit. And so this circuit is a circuit for sensing low temperatures. And the next stage, as I've spoke about already, the next stage will be what happens with that. So that will switch something on or control something when the temperature falls below a certain value. And the value that it falls below, I'll just mention this in passing just now, that's controlled by the variable resistor. Okay, so the opposite circuit, so all I've done here is switched the thermistor and the variable resistor round. So the thermistor's on the top half and the variable resistor's on the bottom half. A lot of this information is exactly the same. This circuit, temperature increases, then the resistance of the thermistor would decrease and the voltage across here would decrease. So therefore, the voltmeter reading is going to increase, because if that gets smaller, that has to get bigger. And therefore, this circuit is for sensing high temperatures. As I said already, the next stage will be, okay, what do we do with that voltage? So the voltage will increase when the temperature increases, and therefore that could then go on and control something else as part of that circuit. This is always a complicated part of the course. I would say it's all extension work. Go through this PowerPoint a couple of times, take notes, try and get your head round about it. You're building on the knowledge that you've got from previously about voltage divider circuits, that the share of the voltage is based on the share of the resistance, and that the voltage across each one of these things has to add up to the supply voltage. So it's a culmination of all of that, and remembering what happens with LDRs and thermistors when either the light or the temperature increases or decreases. So there's a fair bit in there. So just, as I say, go back over it again and then give it your best shot. Remember, I'm always here if you want to ask any questions. I don't think there's that many questions on this stuff that I'm going to post for this week. Next week's one would be when we introduce the next stage of the circuit, which would be control circuits. But good luck with that anyway, and I'll catch you all next week.